Swayam Prabha. Digital India. Educated India.
Okay, so we start with introduction to cryptography. What do we mean by cryptography or cryptology? So, the cryptography is an area by which we can able to communicate two people which are remotely sitting in two different place, and that communication should be in a secure way, and they are communicating over a insecure channel. So, usually these two people, this is the fundamental objective of cryptography. Fundamental objective of cryptography is to enable two people, and these two people name we usually use in the crypto every book or everywhere Alice, and the second person is Bob. So, two people is usually referred as name as Alice and Bob. So, the fundamental objective of cryptography is to enable two people to communicate over an insecure two people for a secure communication over an insecure channel, over a public channel, or so this is the area which guarantee us or which give us confidence to for the secure communication between two party Alice and Bob, and they are communicating over public channels, say telephone, internet, email, Facebook, WhatsApp. So, this area this is the objective of cryptography to it says science of art of secret writing. So, we are communicating over an insecure channel which is public and which can be captured by any party, and but the communication should be secured. So, whatever is sending by the Alice should not be revealed by anybody else other than Bob. So, let us draw the picture. Suppose there are these Alice and Bob in sitting in two different places. Say Alice is sitting in say Delhi or in some part of India, and Bob is sitting say New York or USA. Okay. So, now they want to communicate. So, Alice want to communicate to Bob. So, Alice wants to send a message to Bob. So, message could be anything, like say Bob called Alice and Bob asked, hey, what is your age? So, this is the say age of Alice. This could be a message Alice wants to send to Bob. So, this is say 24. Suppose Alice's age is 24. So, Alice wants to let Bob know that Alice's age is 24. So, if Alice is communicating with Bob over a public channel. So, this channel is public. So, public means it could be telephone, or it could be email, WhatsApp, Facebook, anything. I mean any internet option. So, these are all public channels. So, which is captured by a third party which is named as Oscar. So, Oscar has access to this channel, full access to this channel. Oscar can hear or Oscar can see whatever messages, whatever communication is going on over this public channel. So, Oscar is typically referred as a bad guy. So, Oscar is hearing everything. So, if just Alice send that hey my age is 24, then if Alice pass 24, then Oscar will also come to know that 24 is Alice's age. So, that they Alice they do not want to reveal their age say. So, this is the secret, this is the message Alice wants to send to Bob without revealing this information to the third party. So, what Alice can do, or so this is the whole area of cryptography, how we can securely communicate over an insecure channel. This channel is insecure. Okay. So, now what Alice can do? Alice can do something on the plain text. This is called plain text or message. I will come to that. So, Alice can do something on the plain text. So, Alice can reverse this. So, Alice can, so 24 42, and then Alice can send this 42 back to Bob. Now, upon receiving 42, Bob has to get back 22. So, what Bob will do? So, Bob has to know what Alice did. So, Bob has to again reverse this 42 to get back 24, but if Oscar knows that they just reverse it, then Oscar will also be able to get the Alice original age, which is 24. What else Alice can do? Alice can add something on this, say Alice can add 20 on this, or Alice can multiply 10 on this. So, 10, so maybe Alice can add something on this, say Alice can add say 18 on this or 28 on this, say 26. Yeah, so this would be a round figure. So, Alice is adding 26 on this. So, then it is 50. So, now Alice send 50 over this public channel. Okay. So, 50 is not Alice's original age. So, Alice's original age is 24, but Alice did something, Alice add 26 with it and got a number which is 50. Alice could multiply 3, that is also possible, but this way Alice is hiding this message or this original information. So, 50, now 50 Bob is receiving 50. So, after receiving 50 and Oscar is also receiving 50. So, Oscar will assume Alice's age is 50, but Bob knows that Alice did something. So, Bob knows, Oscar may be also knowing Alice added something, but how much Alice added, that information Oscar will not be having. So, that information, this 26 is typically shared between Alice and Bob. So, this is called key, this 26 is called key or the secret key, which is shared between Alice and Bob. Sorry, this is 26. Okay. So, upon receiving this 50, so what Bob will do? Bob will subtract this 50 minus this key and get back 24, which is the Alice original age. Okay. So, this process is called encryption process, or this is called encryption, what Alice is doing. This is called encryption, and this thing what Bob is doing to get back the plain text, this is called decryption. Okay. And this is called, this 24 is called message or the plain text. Or the plain text, and this 26 which has been added with the plain text to get this 50 is called key, secret key shared between Alice and Bob. So, how they are sharing, that is also another issue. How they, because they cannot just come telephone and say okay, we are going to use 26 as our key, then that 26 will be revealed to the Oscar. So, Oscar also will be getting the key. So, that communication, that how they will get this, how they will agree with this common key. So, that is another issue. So, that has to be done in a secure way, otherwise it will be revealed by the third party. And after encryption, the output is called ciphertext. ciphertext. So, this 50 is the ciphertext. So, this ciphertext is the output after the encryption algorithm. This encryption algorithm is very simple. We are taking the plain text, we have the key, secret key shared between Alice and Bob, and we are adding this, and we are getting the ciphertext, and this ciphertext is being sent over the public channel. And upon receiving this ciphertext, what Bob is doing to get back the plain text, Bob is having the key, Bob is applying the reverse process of that encryption, that is called decryption process. So, encryption was added, so decryption has to be subtraction. So, Bob is subtracting this 26 and get back the plain text, which is 24. So, this process is called decryption process or the decryption algorithm, this algorithm, and this is the key, and Bob has to use the same key. Now, what Oscar can do, the third party. So, Oscar is having full access to this public channel. So, Oscar is receiving this 50, which is the ciphertext, but Oscar is not having this key. So, this key, which is here is 26, is typically with Alice and Bob. So, nobody else is having this key. So, that means Oscar is not knowing what is the key, but Oscar may be knowing that they have added something. So, this encryption algorithm is public. We cannot say that we will not reveal whether we have added or we have multiplied or we have divided, we have used the division for our encryption. That encryption algorithm we make it public. Okay. This is public that we have added something. So, but how much we have added, then that information is not public. So, that key is the secret key, which is shared between Alice and Bob. So, that is here is 26. So, what Oscar can do? Oscar is getting only this ciphertext. Oscar is not having the key. So, Oscar goal of the Oscar is to guess what is the key and what is the plain text, what is the Alice original age. Okay. So, this is the fundamental objective of cryptography. So, this will be knowing this encryption algorithm, decryption algorithm. The study of this is called cryptography, and who does this? The people who are working on it is called the cryptographer. Okay, so this is what Alice is doing. This is the encryption, and what Bob is doing, that is the decryption algorithm. Okay, so can you go to the slide, please? Okay, so here is the cryptography is the science or art of secret writing. So, two party usually referred as Alice and Bob. So, they are communicate. So, fundamental objective of cryptography is to enable two party to communicate over an insecure channel, such a way that the third party Oscar cannot understand what is being said. I mean, so this age should not be revealed by the third party. Oscar should not get what is the age of the Alice. So, this is the some terminology plain text which we have discussed, the information that Alice wants to send to Bob, that age here in this example. Alice wants to send the age to let Bob knows Alice age. So, the age here is the plain text. So, the information that Alice wants to share with Bob is called plain text. So, Alice encrypt the plain text using the predetermined key. So, this key is shared between Alice and Bob, and this is the encryption process. Now, upon receiving the ciphertext, Oscar cannot determine what is the plain text or what is the key, but Bob should able to Bob is having the encryption key. So, Bob should able to decrypt it to get back the plain text. So, this is the typical communication channel. So, we have two party Alice and Bob. So, there is a plain text source of plain text space, and so there is a encryption algorithm. So, in this case our encryption algorithm is very simple one, it is a addition. So, this is typically called SIP cipher. We will formally define what is a SIP cipher. So, Alice is choosing a plain text and Alice is choosing a encryption algorithm, and they shared with a common key. See, the secret key K this is shared between Alice and Bob, and this is done in a secured way. I mean, so that either they can meet with each other at some point of time, and they can decide, okay, this 26 we are going to use for as our key for next 1 year. So, that is one option. They made some December time they made, and they say decided, okay, we are going to use this is our key for our next 1 year communication. But that is also danger, because key may be revealed. So, there is a risk of using the same key for long time. So, we need to change the keys depending on the application in our mobile, how much security whether we should keep the key for 1 day, 1 week, 1 hour, 1 minute. So, maybe our prime minister mobile they change the key in a second. So, every second keys are changing. So, these are called session key. So, it is not a good idea to decide a key and use for it for long time, because it could be revealed. So, this is one problem to share the key. So, this is there anyway, somehow they have to agree with this common key, this k. So, these k are coming from the key source, and this k they have shared over the secure channel. Either they meet with each other, or they trust on somebody to send the key, something like that. And this Oscar is the bad guy, third party, who is the called cryptanalyst, who is ready to break the code, or the hacker. So, he is to guess what is the key. This is the key head, the guessing of the key, or what is the plain text, the message Alice sent to Bob. So, this is a typical communication channel in cryptography. So, cryptography has two components. One is the cryptography, which is which is the area where we know the algorithm like encryption algorithm, decryption algorithm, and how we share the key. All these issues come under this cryptography. And the other side of the coin is the breaking the code, like hacker, the cryptanalyst. So, this is called cryptanalyst, the other side of the coin. So, cryptographer they design the code, and cryptanalyst they break the code. So, their job is to breaking the code. So, this is called cryptanalyst, or the people who are breaking the code are called cryptanalyst, and this area is called cryptanalysis, and the cryptography is to designer who design these algorithms, and combining two area is called cryptology, is basically the whole area of this cryptography and cryptanalysis. Okay, the main two area of cryptography is symmetric key cryptography and public key cryptography. In symmetric key cryptography, Alice and Bob they shared with a secret key k. So, this is single key or symmetric key, and if Alice wants to send a message to Bob, then Alice will apply encryption algorithm, which is basically ek of m, and get a ciphertext, and this ciphertext Alice is. So, this is the encryption algorithm, encryption function or encryption algorithm, and this ciphertext is sending to Bob. And this after receiving this C, so Bob will apply another algorithm, which is called decryption algorithm, which is use the same key on C. This is basically dk of C is basically ek of m. So, it should give us m. So, this is called decryption. So, this is called typically a symmetric key, because we have used the same key or the symmetric key or private key or the single key crypto system is cryptography. Okay. And there are other area which is called public key. So, there everybody is having two pair of keys, because in this case there are many issues like how they share with this key, common key. So, to avoid that, public key was invented after the work of Diffie-Hellman key exchange protocol. They gave a algorithm where Alice and Bob sitting to different place can agree with a common key. So, after that work this public key was invented, but all the conventional cryptography like SIP cipher, Caesar cipher, Playfair cipher all are comes under symmetric key crypto system. Okay, so, so this is the conventional crypto encryption algorithm. This is basically symmetric key. So, we have an encryption algorithm. So, this is used this algorithm use a key which is a secret key shared between Alice and Bob, and this is the plain text which is the input and another input is the key, and it generate basically the ciphertext. This is Alice is doing sender, and this part is receiver is doing, which is referred as Bob. And this is basically we are receiving the Bob is receiving the ciphertext and Bob is having the common key k, and that using that key Bob is decrypting that ciphertext to get the plain text. Okay, so this is the simplified model of. Okay, so come back to the formal definition of a crypto system. So, what do you mean by a crypto system? So, typically a crypto system is a 5 tuple crypto system is basically a 5 tuple P set of plain text, C set of ciphertext, K set of key space, E set of encryption algorithm, D set of decryption algorithm. So, this is called set of all possible plain text, set of all possible plain text, or this is referred as plain text space. And this is set of all possible ciphertext, this is called ciphertext space. And this is the key space, that means set of all possible keys, key space, this is set of all possible keys, and this is the set of all possible encryption algorithm. This is set of all possible encryption algorithm, possible encryption function, or algorithm. So, basically this is a function which is taking this is the function. So, encryption function is basically, if we denote this by E of k, it is basically plain text space, key space to the ciphertext space. This is a function form. So, this is taking a key, if we, so this is taking a key and then a plain text and giving us the ciphertext. So, basically we are E of k of m is basically C. So, this is the plain text, this is the key, and this is the ciphertext. So, we choose a key. Once we choose a key, then our encryption algorithm is fixed, and then we take a plain text and we encrypt it and we get the ciphertext. And this is called set of all possible decryption algorithm, set of all possible decryption algorithm. Okay, so that means this is basically a decryption function, set of all possible decryption algorithm or decryption function. So, a decryption function is typically what are the input. So, input is a ciphertext and the corresponding key, and it will give us the plain text. So, d of k c is basically m, if and only if E k of m is c. So, if this plain text, if this hypertext was derived from the encryption algorithm of after encrypting this plain text using the key k, and then it should give us the ciphertext. So, this is the reverse process. Actually, decryption is the reverse process of the encryption. So, this 5 tuple is called the crypto system. So, but it must have some condition, like for a given key there must exist a encryption algorithm such that, and there must exist a decryption algorithm such that we should, after encrypting a message, we get the ciphertext, and the ciphertext, if we apply the decryption algorithm, we should able to get back the message. So, this is the condition this crypto system should have. So, let us write the condition for every key. So, this is the formal way to define a crypto system. For every key, given a key from the key space, what we can do? So, there must exist. So, this is the symbol we use for there exists a encryption algorithm E k from this encryption space, and a decryption algorithm from this d k, which is basically reverse of this encryption process. So, decryption is basically reverse of the encryption process. In our example, Alice's age was 24, we are adding something on 24, that adding something means that the key is 26. So, the key was 26 and the encryption is just the addition. So, we are adding 24 plus 26 and we are getting the ciphertext. So, but decryption is the reverse. So, and there exists a decryption algorithm such that if we encrypt a message, we get the C. Now, on that C, if we apply this decryption algorithm, we should able to get back M, and this must be true for all M from the plain text. So, that means for a given k, we choose a k. K is typically chosen by the receiver Bob, Alice and Bob. This is the two. This is a symmetric crypto system. So, Alice and Bob typically choose a key k, and they decide this is the key we are going to use for our communication. So, after selecting the k, they should able to have a encryption algorithm. Alice able to choose a encryption algorithm from this set of all possible encryption algorithm space, encryption function, and the corresponding, there should exist a corresponding decryption function such that this encrypting a message will give us the ciphertext, this is C, and if we decrypt the C, it should give us the plain text. And this E C, E k, C k, this function all should be computationally feasible function. I mean, it should not be very hard to compute. It should be computationally feasible. That means, it should be polynomial function. It should not be a hard function like NP hard, NP complete. So, it should be, we should able to encrypt a message, that is the idea, and we should able to decrypt the corresponding ciphertext to get back the message. So, this encryption algorithm, decryption algorithm, they should be communication, they should be computationally feasible. It should not be typically hard problem or something. Okay, so this is the crypto system. In the next class, we will talk about some conventional crypto system, which are called classical crypto system, like SIP cipher, seizure cipher, substitution cipher. Okay, thank you.